Hello and welcome to our last installment of Unit 11 where we're talking about beaches and shores and processes we do to stop it. It's a very dynamic environment. Water trying to rip apart the continents, turn it into sediment, move the sediment around, maybe dump it down onto the abyssal plain, but we do everything we can to stop that. We want the stop motion where we want water to be deep, and we want sand where we want water to be shallow and pretty. First thing we're going to talk about is tectonic or isostatic changes. These are actually things that will change global sea level. Tectonic, we can actually uplift and we can subside, we can push up, and we can drop land masses. We can do it large scale, where we talk about plate tectonics and we build whole mountain ranges like we do on the west coast of the United States. So continental size, and we can also do it much smaller scale, earthquakes, pushing up blocks of land or dropping blocks of land, for which is local deformation. We can also do it isostatically. Isostatically is actually adjusting loads on things. We can put sediment and ice. We can put other things on top of land. And as that happens, the land gets pushed down. And then as mountains ranges get eroded away, and they're actually much lower down here, as the mountain sticks up, it's got to go down here to support the weight, its buoyancy. As the mountain wears away, this root of the mountain actually rises and eventually become flat, and I'll show you an animation as soon as we get done with this slide. And it all leads to changes in, well, actually, the next slide will show that. Global warming will also do it, where we warm up the water, the molecules move faster, they take up more space, and we're actually seeing some of this now. So we can actually dump more water into the ocean by melting ice, but we can also make the water expand by heating it up. All of these tectonic, isostatic, and global warming affect sea level. So let me actually show you this animation. This is a glacial isostasy, and this is going to be ice. But if you watch the continental crust here during an ice age, where we actually pummel ice snow up on top of land, you can see that the land subsides. It also uplifts. So if this was happening close to shore, this would actually push the water into a smaller area, which would raise the water level. Mantle flow moves this way, and then as the snow stops, and as we get out of an ice age, the ice melts and the land will eventually move up and it will subside, and this will allow water to move in, which would lower the level of sea level. Okay, so we got that slide. Next one is called eustatic changes. These are global changes, so all the things we talked about, tectonics, isostasy, and global warming, is going to change the level of the ocean. These can be done by seafloor spreading rates, actually spreading the ocean. If it spreads really fast, water levels will drop. Changes in ice volumes. We melt ice, it turns into water, fills the ocean. We form ice, it comes out of the ocean, lowers the level. Changes in temperature, and then global warming, sea level rises, ice melting, ocean warming. And regardless of who's causing global warming, it is happening. Is it a total man-made effect? Probably not. Probably is some natural stuff out there, although some people will tell you it's all natural and no human. But looking at the increasing greenhouse gases in our atmosphere, something's got to be happening with us. Now we'll talk about the three coastlines on North America, but you can actually equate these to other land masses. The Atlantic coast of the United States, it's also the Atlantic coast of of Europe and Africa. It's mainly a submergent, where we're actually getting the land, where material is falling off the continent, going on to the continental margin, going into the rise and pushing it down. We also have the Chesapeake Bay here on the east coast of the United States is a submerged river valley. You can tell that by looking at it. We also have barrier islands, big sand flows. We have glacially shaped shorelines. We have eroded coastlines, and we have subsidence in most areas. The reason it's called a passive continental margin is because that the plate boundaries are divergent on one side, convergent on the other. So there's the entire plate, and the east coast of the United States is somewhere in the middle. So it's not getting a whole lot of tectonic activity. That's not going to pose true for the west coast of North America or in the Pacific Ocean. Gulf of Mexico, very much like the East Coast, it is a passive margin, so submergent, barrier islands, Mississippi Delta forming, high rate of erosion from the middle of the continent. And we also have tectonic subsidence where, as the sediment goes down from the Mississippi River onto the Gulf of Mexico, that ocean floor, it will actually push things down, causing, bending and tectonic subsidence. Pacific Coast, totally different ball game. It's not in the middle of a plate. It's actually on the edge, real close to this deep ocean trench where we get this plate subducting, this mafic plate subducting, and this felsic plate staying on top. It's mainly emergent. Less erosion. We're not going to get as much water flowing into here. Most of our big rivers come out of the middle part of the country. Mainly rocky shorelines where we're going to get the sea caves, the stacks, the tambolas. We're going to get big rocks out on the water, as well as cliffs close to shore. We have dams actually shutting off the supply of most of the big rivers, like the Columbia, Colorado. So we have those things actually forming, and that starves the beach of sand, and it is a very tectonically active boundary as well. This is coastal erosion and deposition. Erosion are the minuses, deposition are the pluses. It also shows you whether it's sedimentary, whether it's marine, or whether it's an igneous land. And you can see there are a few little igneous things here on the west coast of the United States because of the tectonic activity. You can also see there's large particles of sedimentary rock. Here in Florida, it's mostly limestone, calcium carbonate, and you can see sedimentary rock. And then way up here where we had the last ice age, it is down to bare bedrock, and it's more granites and other things. But you can see minuses, and then pluses and pluses, and minuses and minuses and pluses. You can see where we actually pick up things and where we actually erode things. Hard stabilization, we fight the ocean. We fight the waves, we fight the currents, we fight the tides, and we do this with concrete and rock and reinforced concrete. We have basically two things, or three things we can use, two of them shown here. Groin or groin fields, these are perpendicular to shore. So if this is our shore, we stick them out this way. This usually is sticking out from sand. It traps sand between the groins. It actually makes what's called a groin field that interrupts longshore current, and it messes up beaches for anybody downstream. So if longshore current's going this direction, and remember, as the waves come up here, they bring sand and they go back down, and then the next wave comes in and goes back down, because the waves almost never come perpendicular to shore. And on the east coast of the United States, the longshore current is from the north to the south. Jetties are very similar, but these are usually built along a harbor. They're usually built in pairs, and sand also gets flipped up upstream from that. What's up? This is what happens when teachers come in here. Here's the way the groin actually starts. Here's the original seashore. We put a perpendicular concrete thing up there, and what happens is longshore transport is coming this way, so the waves come up this way, drop up sand, and when they come into here, they slow down, they drop the load. So what we get is we get a buildup of sand on one side, and then as the next wave comes in, which is supposed to have the sand from the last wave, it doesn't. It actually picks up sand from this side, so we get this sculpted out view. And here is a groin field where the original beach was, somewhere around here. We have about the same amount of sand, but because we're actually moving the currents this direction, we get these things. And if you have a beach that is robbed of sand, you're going to put up a groin to try to get more sand up there. Here's another view of closer, and you can see sand on one side, sculpt out one side, sand on one side, sculpt out, and sand. And here's a jetty. Jetties do pretty much the same thing, except that they're usually protecting a harbor. So we're bringing boats in. Piers do the same sort of thing. As you drop those supports down, they will slow down longshore current and will get built up of sand, as you can see there. We can also have what's called breakwater. Breakwaters are usually a concrete line with rocks. They're usually parallel to shore. They're usually offshore. Which is located here, although you can see it goes into the shore, and we get deposition behind it. So longshore current, let's say, is moving this way, it will wrap around refraction and actually dump sand into this harbor, which is not good for the draw of these boats. We can put seawalls up to protect, like this case, barrier islands, or we can actually do that for other things. Built on the beach, they're parallel to the beach, and we can see this barrier island with this house. There's the lagoon. Here's the mainland. That's an inland waterway. Here's the ocean. Waves come in here. We want to protect that sand, so we actually put down into the earth a concrete wall. And what we find happening is the waves come in and they actually will go down and they'll take the sand from the bottom of this wall, and eventually that wall will fall down and the beach disappears and the house goes in. So the erosion enhances the seawall, is enhanced by the seawall side of the wall. So this side pulls away the sand, seawall is destroyed, beach is narrowed, and kind of defeats the purpose. Alternatives to hard stabilization is limit construction near shore. Don't build on barrier islands, although I like to vacation on barrier islands, and I really would like to have a house on that island rather than have to drive, to one of the bridges to get back to the mainland for like a hotel or a house for a week, and then go out to the beach. We can also relocate businesses. We can also plant plants. These are sea oats, and you can see the sea oats are actually holding the sand. This is a way we can get to the beach, but you can see that there's less sand there. And we can put other kind of grasses. We can put fences, anything to slow down the wind, which would pick up the sand and move it. And that is the end of Unit 11, the coast, the beaches, the shorelines, the processes. We do everything we can to protect this land from that ocean. And you can see barrier islands, you can see cut-throughs, whether they're natural or not. You can see roads going across it. We want to make sure that road stays there and clean. You can see breakwaters, you can see, I don't see any jetties, piers, or groins, but you can see that protecting this harbor. There's another spit coming out this direction protecting this harbor, almost a bay mouth bar, and they're going to do everything they can to make sure this doesn't close. Probably dredging this canal. You can see all the sand that gets placed out there, and boats, if you want to go out into this, whatever body of water this is, you're going to do whatever you can to protect it. Okay, thanks for stopping by. Appreciate it. Off to